Let's analyze the graph of the area of a rectangle with a perimeter of 25 meters and a side length x shown. We know the graph is of a quadratic function because it has a U-shape. Quadratic functions can have up to 2 zeros or x-intercepts. This function has 2 zeros, the point 0, 0 and 12.5 0. Since this graph represents the area of a square with side length x, the zeros represent side lengths of the square that would cause the area of the square to be 0 or non-existent. The vertex of a quadratic is also the maximum or minimum of the function. In this scenario, the vertex is also a maximum since it's the highest point on the graph. The vertex has an x value of 6 25/100ths and a y value of 39 63/1000. This point represents the maximum area of a square and the side length that would cause it. The domain of any function is the set of all the possible x values. In a generic quadratic function, the domain is all real numbers. For this graph, since the x values are possible side lengths and the y values are the area of a square, we need to find a reasonable set of values. The x values cannot be negative, and the y values cannot be 0 or negative. Therefore, the domain for these functions would be 0 is less than x is less than 12.5. The side lengths of the square need to be between 0 and 12.5.